Crash Course Instrumentation, Episode 16, Real-World Source, Load Modeling and Series Wrap-Up. Introduction. We've talked theory. We've done the math. But how do real techs actually apply source and load modeling in the field? Welcome to the final episode of our Sources and Loads series on Crash Course Instrumentation. Today, we'll connect the dots with practical models, real-world examples, and a quick recap of the big ideas. Review what we've learned so far. Here's a rapid-fire summary. Voltage sources. Supply energy, modeled as ideal sources, plus internal resistance. Shows loads. Consume energy, resistors, sensors, transmitters, control circuits. 3. Ohm's law and power formulas. Let us predict how current and voltage behave. 4. Conservation laws, energy and charge, are always in effect. 5. Sourcing versus sinking, matters for circuit design and safety. 6. Thevenin and Norton equivalents, simplify complex networks. 7. Superposition helps break down multiple sources. 8. Maximum power transfer reveals the sweet spot between power and resistance. Real-world models, instrumentation examples. Example 1. 24-volt, DC, power supply plus pressure transmitter. The supply is a voltage source with low internal resistance. The transmitter is the load, often modeled as 250 ohms, loop-powered. We use the source load model to estimate voltage drop across the wiring and ensure reliable current to the transmitter. Example 2. Thermocouple plus PLC input. The thermocouple acts as a low-voltage source with very high internal resistance. The PLC input must be modeled as a high-impedance load to avoid distortion. Mismatched impedance here equals bad readings. Example 3. Analog signal into a controller. Output cards driving multiple loads must be checked against total current draw. Each connected load drops voltage. Too many loads? Your signal dies. Modeling as a thinking tool. Here's why source load thinking is so useful. It lets you predict problems before they happen. You can isolate faults faster during troubleshooting. It helps you understand why. Voltage drops, loops fail, or devices misbehave. It's not just theory. It's a way to think like a technician. Instrumentation technician pro tips. Always check voltage rating and load requirements before wiring. Source impedance when using analog sensors. Load characteristics when designing 420 mm loops. Perform tug tests after terminating your wires. Use modeling tools or spreadsheets when estimating drops across long cables or multiple loads. Don't forget about derating. Heat and cable length change resistance values in the real world. Wrap up. End of series recap. That's a wrap on our Sources and Loads series. Here's what we've accomplished. We broke down voltage and current behavior. We learned how to model, simplify, and optimize electrical systems. We tied theory to real-world systems that techs see every day. Understanding source/load behavior is foundational to all of instrumentation. Everything from loop design to PLC integration depends on it. Next time, we'll kick off a brand new series on electrical components, starting with resistors, capacitors, inductors, and beyond. Subscribe, like, and share this series with anyone trying to level up their instrumentation game. La Instrumentation, Control Systems God Instrumentation Tech nar I plant.